This is a short video on the details filling in the analysis of variance table. We're not going to do a problem or anything. I'm just going to show you where numbers go and all the other pertinent details. So let's begin. ANOVA, analysis of variance. And the variance comes from these two groups, or these two rows. The first one is the treatments. This is just another way of saying samples. Let's write that here. So this is the samples, and this is the variance associated with the observations. And if the sample variance is substantially larger than the observation variance, we will have a significant result. Some notation. If they're talking about sum of the squares of the treatments, SSTR is how it's going to be written. If they're talking about between groups, this will be SSG. For errors, the observations, this will be SSE, or sometimes SSW, W for within groups. Everything adds up vertically, so this is the total sum of squares. All right. The point is most of these will be given, and if you aren't given a particular value, you will have an easy way of figuring it out. Now, as far as the degrees of freedom go, this is based on sample size here. This will be k minus 1, where k is the number of samples, or the number of treatments, or the number of groups. So if you have 5 treatments, or 5 samples, you'll put a 4 in that box. This is big N minus k, where big N is the total number of observations. So 5 groups, each of 20, will give you 100. And then, of course, 100 minus 5 gives you 95 in the example we're talking about there. And this is just for bookkeeping. This will be N minus 1. We'll use that in further courses if we need to. To figure out the mean squares, we start by taking the sum of the squares and dividing by the degrees of freedom to get our mean squares. This is notated as MSTR, or if they're using between groups, MSG. Here we have MSE, or MSW, again the same computational method. This divided by this gives you that. Our test statistic F comes from these two values. MS treatments divided by MS errors gives you your test statistic. If you need the critical value for F, this will be given. Now, a couple of things to note. This is your pooled or common variance. Now, oftentimes you'll be asked for the pooled or common standard deviation. So take the square root of that value to answer that type of question. Reporting the distribution of the test statistic under the null hypothesis means we're going to write capital F with k minus 1 degrees of freedom there and n minus k degrees of freedom here is equal to whatever the number happens to be. Null hypothesis for this topic. All the means have roughly the same value. Now, to have a significant result means at least one of these is different. They don't all have to be different. You only need one to be different, so we write at least one mu differs from the others. And that's pretty much all there is to filling out the analysis of variance table. I'll do a larger, more complicated example in a longer video. But this ends this video here.